Okay, we went over where the identities came from and even did some examples in the room. This is going to recap but also add some more information. Okay, use the value secant of u equals negative 3 halves and tangent u is greater than 0 to find all 6 trig functions. This is all about drawing a triangle. If tangent is positive and secant is negative, which means okay, tangent is positive, secant is negative, which means cosine is negative. What quadrant am I in? All students take calculus. Tangent's got to be positive, so I know I'm in first or third. Cosine's got to be negative, so I have to be in third. So as long as you set it up correctly in the right quadrant, you know secant is negative 3 halves, so that is your hypotenuse. Hypotenuse is always positive. Adjacent, that's where the negative goes. And then we solve for the missing side. Square root of 9 minus 4 would be square root of 5. That's going to be negative because it does go down. And then find the sine, cosine, and tangent from that triangle. So then we will have, here's theta, sine theta, negative radical 5 over 3. Cosine theta, negative 2 thirds. Tangent theta, opposite over adjacent, radical 5 over 2, negatives cancel. Then we do the reciprocals, the cosecant. We're going to have negative 3 over radical 5, no need to rationalize. Secant theta, negative 3 halves, you better get that one right. And cotangent theta, 2 over radical 5. Okay, you try setting up this triangle and seeing if you can get them all on your own. If my sine is positive and my cosine is positive, I have to be in quadrant 1. Sine is 1/2. Here's x, so sine opposite over hypotenuse. And then solving for my missing side would be 4 minus 1, so radical 3. Alright, sine x equals 1/2. Cosine x, radical 3 over 2. Tangent x, 1 over radical 3. Cosecant x, 2 over 1, or 2. Secant x, radical 3 over 2. And cotangent x would be just radical 3. Oh, I did not flip secant. That should have been 2 over radical 3. Okay, we're going to try some simplifying again. First of all, it's usually easier if you can get this all into one, so that maybe we can have some of these terms cancel. If you take cosine squared x, that is in your identity sheet right there. Oh, drew through it. Okay, it's that first Pythagorean theorem identity. If I take that identity and rearrange it, I can get it to say cosine squared u equals 1 minus sine squared u. And that's exactly what I'm going to replace in my expression. So instead of cosine squared x, I'm going to replace it with these parentheses. So then I'm going to have sine x, parentheses, 1 minus sine squared x, just changing the variable u to x, minus sine x. I'm going to distribute this sine x in. Sine x minus a sine x times a sine squared x is going to be a sine cubed x minus sine x. And I'm going to simplify. This sine x and this sine x are going to cancel each other out, and all I'm going to be left with is negative sine cubed x. Okay, give this one a shot, see if you can figure out what to do. In this one, and we could have done this in the last one too, but let's think about they have cosecant x in common. They have a common term, so if we factor that out, we're going to get cosecant x on the outside with cosine squared x minus 1 on the inside. And we know that cosine squared x minus 1, if I take my identity, sine squared x plus cosine squared x equals 1, and I rearrange it, that's going to say cosine squared x minus 1 equals negative sine squared x. So now I have cosecant x times negative sine squared x. Cosecant x can be rewritten as 1 over sine x times negative sine squared x. So now I am, see, a positive times a negative, it's going to be a negative. I have sine squared x on top over sine x. Cancel one of those on top with the one on bottom. I'm only left with negative sine x. Okay, let's do the same problem a different way. If we use the replacing like we did in the very first example, I can replace cosine squared x with 1 minus sine squared x. I can change cosecant to 1 over sine x and the other cosecant to the same. So now I have 1 minus sine squared x over sine x minus 1 over sine x. Then, when you have this two terms in your numerator, one term in your denominator, you can split it into two fractions. Split it into 1 over sine x minus sine squared x over sine x minus 1 over sine x. That was already there. Then you'll see these two are going to cancel each other out. I'm going to be left with negative sine x once again. We're going to talk about factoring a trig expression. Factoring happens just like it did in algebra. If you think of this as being x squared minus 1, you should know that that factors into x plus 1 and x minus 1, because the 1 is a perfect square and square is obviously a perfect square. It's your difference of squares rule. So my secant squared minus 1 is going to factor out into secant theta plus 1 and secant theta minus 1, and that's it. Here's a different type of factoring. If I take out the tangents and replace them with x, this is just like factoring 4x squared plus x minus 3. And if I break this into two parentheses, because it's not a perfect difference of squares, you guys learned in multiple different ways how to factor, and I'm not going to go over any of them right here, so if you need it, Google it. These first two terms have to multiply to give me 4x squared. So I'm going to try 2x and 2x. These last two terms have to factor to give me negative 3, so negative 3 and positive 1. Then I have to check and see if I get the correct middle term. So 2x times 2x, yes, I get 4x squared. 2x times 1 plus 2x, that gives me negative 6x, and then negative 3. So did my middle term turn out? No. So I'm going to try 4x and x, and think a little bit ahead before I make my next decision. If I put a 1 there, I'll have a 4x. And if I put a 3 here, I'll have 3x, so I could subtract them both. And which one do I want to be positive? The 4. So that's going to give me 4x squared plus 4x minus 3x minus 3, and that's going to check out. So over here, when I go back to tangent, this is going to be parentheses 4 tangent theta minus 3, parentheses tangent theta plus 1. Try factoring this one. This is like the first one we did. This would be like factoring 1 minus x squared, 1 minus x, 1 plus x. Doesn't matter which order you go in. So this is going to become 1 minus cosine x, 1 plus cosine x. Okay, try factoring this one. It's like the second example we did. You could rewrite it with x's. 2x squared minus 7x plus 6. That's going to factor into 2x and x. And this is going to have to be 3 and 2. Let's see, that gives me 6 and 2. Nope, that's not going to work. Okay, so what about negative 2 here would give me negative 4, and then a negative 3 here give me negative 3, so then I'm going to get to negative 7. So now it's going to factor into 2 cosecant x minus 3, and then cosecant x minus 2.